Ventilation or breathing is controlled by both pressure and resistance. In the last video, we talked about how the diaphragm and other muscles help to change the pressure in the thoracic cavity so that air either flows in or out. This video, we're going to talk about the resistance component. Now, resistance is anything that opposes flow or anything that makes flow more difficult. And in the respiratory system, there are two sources of resistance. One is the diameter of the airways, and the other is called alveolar compliance or pulmonary compliance. First, let's talk about the diameter of the airways. Now, most of the airways in the respiratory system are rigid structures. Recall that the larynx and the trachea and the bronchi are all rigid tubes that have cartilaginous rings along them in order to keep the airway open. That means that these airways cannot really change their diameter in order to change airflow. The only structure in the respiratory system that's capable of changing its diameter and therefore changing airflow is the bronchioles. The bronchioles are the very smallest tube, and they're the ones that are directly connected to the alveoli. The bronchioles, their walls are made with smooth muscle instead of having cartilaginous rings, and that means that if the muscle relaxes, the airway dilates, and if the smooth muscle contracts, the airway constricts. So the bronchioles help us to regulate how much air is going in and out by changing resistance. If I'm exercising, for instance, then my bronchioles will dilate, and those dilated bronchioles will allow more air to reach the alveoli to support my exercise. If I am relaxed and not exercising, then the bronchioles will constrict because I don't need as much air in order to support my metabolic activity. The other component of resistance is alveolar compliance. Compliance is a measure of how stretchy the alveoli are. So if you tell the alveoli to inflate, do they comply? Do they inflate? Or do they not comply? To give you an example of what this means, I think all of us have probably had the experience of buying cheap balloons when you try to blow them up and it feels like your head's going to explode. That balloon does not have good compliance. We're telling it to inflate and it's not inflating. But if you buy nice balloons and you blow on them, they practically inflate themselves. Those balloons have good compliance. And we want our alveoli to have good compliance, to be easy to stretch when we breathe in. And that is accomplished by something called surfactant. So, before I tell you about surfactant, let's take a pause for a second and talk about water, which you probably haven't talked about much since Bio 23. Now, if you recall, water is a polar molecule. So here's oxygen and two hydrogens. And remember that the oxygen has a partially negative charge, and the hydrogens have a partially positive charge. So when you put water molecules together, they form hydrogen bonds between the partially negative oxygen and the partially positive hydrogen. These hydrogen bonds, even though each individual bond is weak, all of those hydrogen bonds together give enough strength that it pulls the water together. This is why if you spill a drop of water on a countertop, it beads up like this instead of spreading flat. Or if you fill a glass with water, you can actually pour water into the glass over the top of the glass and the water won't spill out. Both of these are because the hydrogen bonds between the water molecules are pulling the water molecules together. They want to stay together. And this is called surface tension. The surface tension of the water is how much the water is pulling other water molecules towards it. Now, surface tension is a good thing if you want to fill your glass with extra water. But inside the alveoli, which are lined with fluid, have to be lined with fluid in order to keep the alveoli from drying out. This water wants to move towards the other water molecules. So the surface tension of the water is actually pulling the alveoli closed and in order to create a droplet of water. Now, if the water is pulling in and you want the alveoli to stretch, then the alveoli are not going to have good compliance. It's not going to be easy to inflate. So, there are cells in our lungs that produce something called surfactant. And surfactant is like a detergent. When you mix a detergent with water, it breaks the hydrogen bonds, and now there is no surface tension. The water molecules aren't going to try to pull together. So the cells that secrete surfactant make it so that there is no water surface tension, and now the alveoli can inflate easily. Now, there are cases where babies are born prematurely and they do not yet produce surfactant. This produces something called respiratory distress syndrome in infants, and that's because their tiny little weak chests and their weak little diaphragm are not enough to overcome the compliance of the alveoli. They can't inflate their lungs. They've got those awful cheap balloons that they can't blow up instead of the decent ones. And so when a baby is born premature like that, there is a spray, an inhalant that they give the infant that has surfactant in it that helps to make the lungs stretchy. Now, each one of these can cause problems or lead to ventilation disorders. When there is a problem with or extra resistance in the airway diameter, it leads to what we call obstructive disorders. All right, obstructive disorders are things like COPD, which stands for chronic obstructive pulmonary disorder, asthma, emphysema, bronchitis. So each one of these diseases or disorders has its effect on the respiratory system by making the airways narrow, or by obstructing the airway, making it more difficult to get air in or out. So in the case of asthma, in a severe asthma attack, one of the things that happens is that the bronchioles constrict when they're not supposed to. Another thing that happens in asthma and also in bronchitis is if you look at a cross-section of the trachea and the bronchi, which should have a nice wide opening lined with epithelial tissue, right, our respiratory epithelium. So the opening should be big like that. But what happens is that chronic inflammation develops in the bronchi, and that inflammation, remember, inflammation always comes with swelling, that inflammation causes this tissue to become thicker, and the result is that it narrows the opening of the airway, leading to an obstructive disorder, something that obstructs or gets in the way of air flowing in or out of the lungs. Now, if the issue is with pulmonary compliance, then that means that there's something that's preventing the alveoli from expanding completely when we inhale. And this leads to disorders known as restrictive disorders. Some examples are cystic fibrosis, tuberculosis, and for reasons I'll explain shortly, pregnancy and obesity. So we talked about how surfactant breaks the surface tension of water and allows the alveoli to stretch. But in some disorders like cystic fibrosis and tuberculosis, there are fibers, scar tissue, that develops that surround the alveoli and prevent them from expanding all the way. So it makes them rigid or stiff. The other, pregnancy and obesity can lead to a restrictive disorder simply because they interfere with the ability of the diaphragm to contract and move down. So when a woman is pregnant, the fetus, as well as her abdominal organs, is pushing up against the diaphragm, and that means that it's more difficult to take a deep breath. She can't inflate her lungs all the way, and that's a restrictive disorder. Obesity is the same thing with extra body fat. That body fat prevents the abdominal organs from being able to move out of the way of the diaphragm, and therefore it becomes harder to take a deep, full breath. Restrictive disorders, I like to think of as, well, I use the example of jeans because I grew up before they put spandex and things in jeans. And so putting on a new pair of jeans or jeans that were freshly washed always meant that they were a little bit too tight and a little bit too stiff. So they're restrictive, they're tight, they keep you from relaxing and expanding. Restrictive disorders are disorders of compliance. Obstructive disorders are disorders of the bronchial airway or the radius diameter of the airway.